All right, let's jump right into one of algebra's key building blocks, polynomials. Let's get to it. So you've probably seen expressions like this all over the place. But what actually makes something a polynomial?
Okay, the one rule you have to remember is this. The power of any variable has to be a whole number.
So check this out. An x squared is fine, but see that negative or fractional power? That's not a polynomial.
Every polynomial has these basic parts, but pay close attention to the degree. That's the highest power. It's super important.
Right? So how do we organize these things? Well, it all comes down to two main things, terms and degree.
So take something like x squared minus 2x plus 3. We'd call that both a quadratic and a trinomial.
And here's a weird little detail. A constant, like the number 2, actually has a degree of 0. But 0 itself, undefined.
Okay, we've got the basics down. Now for one of the most important ideas about them. They're zeros. So what's a zero? It's just the magic number for x that makes the whole thing equal 0.
And here's the cool part. On a graph, the zeros are just the spots where the line hits the x-axis. Finding the number of zeros is super easy. Just count how many times the curve hits that horizontal x-axis. But what if you don't have a graph? Simple. You just set the whole polynomial to 0 and solve for x.
For quadratics, a great trick is middle term splitting. You're looking for two numbers that add up to b and multiply to ac.
So once we have those zeros, something really cool happens. There's this amazing link between the zeros and coefficients. Let's take your standard quadratic. We'll call its two zeros alpha and beta, just to give them a name. Get this, the sum of those zeros is always just negative b divided by a. What a great shortcut. And it doesn't stop there. The product of the zeros? It's just c over a. This connection is super powerful. All right, let's recap. These are the key things you absolutely need to know, especially for your board exams. So this whole thing is a two-way street, which makes you wonder, could you rebuild the polynomial just from its zeros?